Okay, let's dive right into this. Welcome everyone to this explainer. Now, I know advanced Python concepts can sometimes feel a little abstract or maybe even deeply technical, but don't worry. Today, we're going to break down Python generators together in a way that makes absolute perfect sense. Because whether you're dealing with massive data sets or you're just looking to write cleaner, far more efficient code, I promise you, generators are a literal game changer. So let's get started. Here is our roadmap for today, and we're just going to take this one step at a time. We'll start with understanding the core concept of Python generators, move into some real-life analogies, explore the specific types of generators, walk through a step-by-step code guide, and then finish up with some highly practical coding scenarios. All right, let's kick things off with Section 1, Understanding Python Generators, the core concept. Let me ask you this. Have you ever run out of memory while running a Python script? Seriously, have you ever tried to process a massive data set, maybe a CSV file with millions and millions of rows, and suddenly your computer fans start screaming, the whole system freezes up, or Python just throws that devastating memory error right on your screen? It's incredibly frustrating, right? But honestly, it's a very common beginner struggle when we rely on slow, bulky lists that try to load absolutely everything into memory all at once. And that specific pain point is instantly going to show you exactly why the tool we're focusing on today matters so much. So what's the elegant solution to that awful memory crash? Well, it's the generator. By definition, a generator is a function that returns an iterator that computes values on the fly instead of storing them all in memory. So the absolute crucial point here is this. Instead of demanding all your system's resources upfront to calculate every single item in a massive sequence, a generator is incredibly patient. It calculates just one single value, hands it directly to you, and then essentially goes to sleep until you explicitly ask for the very next one. Now, what's really interesting about this comparison is the stark difference between our traditional coding approach and this new memory-saving method. Think about regular functions. They use a standard return statement, right? That means the function computes everything, builds the entire list in your system's RAM, and stores the whole shebang in memory before handing it back to you. It's a very heavy all-or-nothing approach. Versus generators, which introduce a magical new keyword, yield. When Python hits yield, it pauses execution entirely. It yields just one value at a time, saving massive amounts of memory because it only ever has to hold that single current value in its head. Let's move to Section 2, Real-Life Generator Analogies, Grounding the Concept. To really make this click, think about a baker at a busy breakfast diner. They make one slice of toast right when you order it, rather than aggressively baking an entire loaf of bread before serving you anything at all. You get exactly what you need right when you need it with zero wasted effort. Or, an even better example, think about how we consume media today. When you stream a movie online, you don't sit there waiting to download the entire massive 50-gigabyte 4K video file to your hard drive before you can watch the opening scene, do you? No way. You watch the data frame by frame as it arrives over your network. And this brilliantly illustrates how generators actually function in everyday logic. They just stream the data to your program piece by piece, pausing in between. All right, on to Section 3, Types of Generators, Yielding the Details. Let's see how this builds. Now, I want to keep our pace really deliberate and gentle here. The great news is that there are essentially only two main ways to create generators in Python, which keeps things beautifully simple for us. First up, we have generator functions. These look almost identical to the standard def functions you already write every single day. But instead of finishing up with a return statement, they use the yield keyword. That's it. Second, we have generator expressions. If you're familiar with list comprehensions, those handy one-liners tucked inside square brackets, generator expressions are just condensed, highly memory-efficient versions of those. The only syntactic difference, you just use parentheses instead of square brackets. Super simple. Let's put this into practice in Section 4. Step-by-step code guide, building our first generator. I'm not going to throw a massive block of code at you. Instead, let's walk through these 3 steps methodically to build your very first generator from scratch. Step 1, just define the function using your standard Python syntax. Start with def, name your function, add your colon. Easy peasy. Step 2, now here is where the magic happens. Use the yield keyword instead of returning a list. Yield is that magical pause button we talked about that brings our toast and our streaming analogies to life. Step 3, to actually trigger the generator and pull data out of it, you simply iterate through the object. You can plug it directly into a standard for loop, or you can use Python's built-in next function to manually ask for the very next value, one at a time. Just look at this beginner-friendly code snippet. We defined simple underscore generator followed by yield1, yield2, and yield3. That's literally the whole thing. Notice how clean and totally unintimidating that syntax actually is. If you run this, when Python hits yield1, it hands you the number 1 and then completely freezes its internal state. When you ask it for the next value, it wakes up, drops down to the next line, gives you the number 2, and immediately goes back to sleep. It honestly doesn't calculate or even care about the number 3 until you specifically request it.
So where do we actually use this? Let's cover that in Section 5, Practical Coding Scenarios, where to use them in the wild. Let's explicitly connect our coding approach back to those awesome memory-saving benefits we talked about earlier. First scenario, reading a massive server log file. We are talking gigabytes of raw text here. Instead of crashing your computer trying to load all of it into a single list, you use a generator expression to read it dynamically, line by line. Second scenario, processing infinite data streams. Imagine pulling data from a live stock market ticker. The data literally never stops coming, so mathematically, you just can't store it all in a list. You have to use a generator function with yield to process that stream as it arrives. And our third scenario, replacing bulky list comprehensions. If you just need to calculate the sum of a massive series of numbers, don't build a giant list with square brackets. Just wrap your logic in parentheses to create a generator expression. You get the exact same answer but using a tiny fraction of the memory.
As we wrap up our lesson today, I really want to leave you with this single guiding principle. Compute as you go, not all at once. That brief phrase perfectly summarizes the entire underlying philosophy of Python generators into one easily memorizable takeaway. From now on, whenever you write code, just pause and ask yourself if you truly need all of the data right this second, or if you can afford to just compute as you go.
You are now equipped with one of the most powerful and efficient tools in the entire Python language. So my final question to you is this. Now that you're no longer artificially limited by your machine's memory, what massive data set are you going to conquer next? I really hope this explainer empowered you to start writing cleaner, faster, and much more Pythonic code. Stay curious, keep building, and we'll see you next time.